Hello students, this is Prabhas Sharma, Assistant Professor, Department Electronics and Communication, Oriental Institute of Science and Technology, Bhopal. So today's my lecture topic is Sampling Theorem. This topic comes under the subject Digital Communication. First we start with continuous time versus discrete time signals. We have two types of systems, continuous time system and discrete time system. Continuous time systems are good for the analog and the general understanding, approximate mostly to analog electronic systems. We are applying xt to the electronics and we are getting yt at the output. Electronics are increasing digitally. Mobile phones, all the digital TV broadcast will be 100% digital. We are using now digital chips, FPGA, microprocessors to implement systems and to process the signals. We have to convert the signal from analog to digital and process and convert it back. Here the diagram where xt is converting into xn by the A to D converter. Then we are giving this xn to computer. Output is yn. Xn and yn both are digital signals. Again we are converting this digital into analog and yn is converting into yt. Sampling process. What is sampling process? Sampling process is a bridge between analog to digital signal. Sampling is nothing but a process which convert an analog signal into discrete signals, which convert xt into xn. xt is an analog signal and xn is discrete signal. We are taking xt and converting into xn. xn equals to x of n ts, where ts is uniform sampling. Here the example, suppose we are taking xt is of f equals to 100 Hz. So the sample signal fs equals to 2 kilohertz or fs equals to 500 Hz. Sampling frequency must be greater than the message frequency. Sampling theorem. What is sampling theorem? Most important topic, sampling theorem. According to the sampling theorem, a continuous time signal xt with frequencies no higher than fm Hz can be completely reconstructed from its samples xn equals to x of nts if the samples are taken at the rate fs equals to 1 by ts, which is greater than twice of f maximum. Message frequency is fn. That means if a message signal is of frequency fm, so the sampling frequency fs must be greater than or equals to twice of fm according to the sampling theorem. For example, we are taking in the previous slide we have seen that message frequency is 100 Hz. We need to sample at higher than 200 Hz because according to the sampling frequency fs must be greater than twice of fm. So fm is 100, so fs must be greater than 200 Hz, that is 200 samples per second. In order to not to lose any data, that is able to reconstructed our original signal of 100 Hz. Fmax refers to the maximum frequency component in the signal, that is significant energy. So the sampling frequency and sampling rate. The sampling frequency fs must be greater than twice of fm and the sampling rate ts must be less than 1 by 2 fm, where fm is message signal frequency. Sampling theorem proof. First proof, we are considering a signal xt, analog signal. This is a time domain. In the frequency domain, we are supposing the signal is x of omega minus 2 pi b to plus 2 pi b. The bandwidth is b. Bandwidth is b. We are multiplying this analog signal by the train of impulse del tst. Del t. Del t is impulse signal. Del tst means train of impulse. Train of impulse is nothing but periodic impulse signal. We are multiplying analog signal with the train of impulse. So we are getting sampled signal. We are getting sampled signal xt multiply with del tst. We are getting x bar t. X bar t is sampled signal. X omega is frequency domain of xt. Omega s del omega st, which is frequency domain of del tst. We are multiplying in the time domain. In the frequency domain, they are convoluting. We have read the property, convolution property. The multiplication in time domain is equal to the convolution in frequency domain. As we all know, the Fourier transform of train of impulse is again train of impulse. So ठीक है, तो टाइम डोमेन में मल्टीप्लाई हो रहा है, फ्रिक्वेंसी डोमेन में कन्वल्यूट हो रहा है, तो जो xt का फ्रिक्वेंसी डोमेन है वो शिफ्ट हो रहा है ट्रेन ऑफ इम्पल्स पर. वी कैन सी एट द लास्ट डायग्राम दैट fs is greater than twice of b. fs is greater than twice of b. What is b? B is the frequency of the message signal. So fs is greater than twice of b. Now the proof of sampling theorem 2. Suppose this is the frequency domain of sampled signal. Frequency domain of sampled signal x bar omega. The next sample is at fs and the frequency of message is b. So b plus b, twice of b. That means fs is greater than twice of b. It is clear by the diagram. इस diagram से हमें clear है कि जो fs है, fs फिर twice of fs, thrice of fs, वो आप जो है आपका है twice of b से ज़्यादा है. This is only possible if the shaded part don't overlap. That means fs must be more than twice that of b. ठीक है, अगर ये जो हमारा fs है उसकी वैल्यू twice of b से ज़्यादा होना चाहिए. Next proof, mathematical proof. What is x bar t? Sampled signal. Sampled signal is equal to xt multiply with del tst. Xt is massive signal, that is analog signal. Del tst is periodic impulse, that is train of impulse. We are multiplying analog with the train of impulse and we are getting sampled, that is x bar t. What is del tst? Del tst is train of impulse. तो train of impulse को हम क्या लिखेंगे? Summation of del of t minus nts. That means del t function every ts के बाद अपने आप को repeat कर रहा है. ठीक है, जो del ts फंक्शन है वो हर ts के बाद अपने आप को repeat कर रहा है. तो del tst को आप लिख सकते हो 1 by ts, 1 plus twice of cos omega st plus twice of cos 2 omega st and so on, where omega is equals to 2 pi by ts. ये आपने निकाला फोरियर सीरीज से. एनालॉग कम्युनिकेशन में हमने पढ़ा है, हमारे पास अगर नॉन पीरियोडिक फंक्शन होता है तो हम उसे फाइंड आउट करते हैं फोरियर ट्रांसफॉर्म से, और अगर हमारे पास पीरियोडिक फंक्शन होता है तो हम निकालते हैं फोरियर सीरीज. हम लोग यहाँ पर निकाल रहे हैं फोरियर सीरीज डेल टी एस टी. देयरफॉर x bar t equals to, we are putting the value of del tst, we are getting 1 by ts xt plus twice of xt cos omega st plus twice of xt cos 2 omega st and so on. Since twice of xt cos omega st is nothing but x of omega minus omega s plus x of omega plus omega s. अब ये कैसे आया? ये आया आपकी प्रॉपर्टी से, xt मल्टीप्लाई विथ कॉस ओमेगा एस टी. ठीक है, हमने ये एनालॉग कम्युनिकेशन में न्यूमेरिकल सॉल्व किए हैं. एफ टी मल्टीप्लाइंग विथ कॉस फंक्शन, कॉस को हम एक्सपोनेंशियल में कन्वर्ट करेंगे, आपकी लग जाएगी फ्रिक्वेंसी शिफ्टिंग प्रॉपर्टी. सो बाय यूजिंग द फ्रिक्वेंसी शिफ्टिंग प्रॉपर्टी वी आर गेटिंग एक्स ऑफ ओमेगा माइनस ओमेगा एस प्लस एक्स ऑफ ओमेगा प्लस ओमेगा एस. सो एक्स बार ओमेगा विच इज इक्वल्स टू 1 बाई टी एस summation of n equals to minus infinite to infinite x of omega minus n omega s, which is same as shown in the previous slide. That means x bar omega, the Fourier transform of the sampled signal, is equals to 1 by ts summation of n equals to minus infinite to infinite x of omega minus n omega s. That means जो मैसेज सिग्नल का फ्रिक्वेंसी डोमेन है वो शिफ्ट हो रहा है एवरी ओमेगा एस पर. एवरी ओमेगा एस पर मैसेज सिग्नल का फ्रिक्वेंसी डोमेन आपका शिफ्ट होगा. दिस इज अ प्रूफ ऑफ सैम्पलिंग थ्योरम. Now, the Nyquist frequency and the Nyquist sampling rate. If the message signal frequency is Fm, so thus according to the sampling theorem, Fs must be greater than twice of Fm. But if Fs equal to twice of Fm, it is known as Nyquist frequency. And according to the sampling theorem, Ts must be less than 1 by 2 Fm. But if Ts exactly equal to 1 by 2 Fm, it is known as Nyquist sampling rate. Next is aliasing. If the message signal frequency is Fm, so according to the sampling theorem, if the sampling frequency is less than twice of Fm and the sampling rate Ts is greater than twice of Fm, then the aliasing occurs. Aliasing is very important concept in the sampling theorem. So we have concluded this topic. What is sampling? Sampling process. Sampling process is a bridge between analog to digital signal. By the sampling theorem, we are converting analog signal into discrete signal. And what is the condition of sampling theorem? Condition is Fs must be greater than twice of Fm. What is Fs? सैम्पलिंग फ्रिक्वेंसी आपकी मैसेज फ्रिक्वेंसी के ट्वाइस से ज़्यादा होना चाहिए. अगर आप मैसेज सिग्नल ले रहे हो 1 किलोहर्ट्ज़ का, तो आपकी जो सैम्पलिंग फ्रिक्वेंसी है वो मोर देन 2 किलोहर्ट्ज़ होना चाहिए. ठीक है, दिस इज द कंडीशन ऑफ सैम्पलिंग थ्योरम. इफ द सैम्पलिंग थ्योरम नॉट फॉलोज, then we are not able to recover our original signal. We get some distorted signal. Okay. Thank you for this video. For more details, you can contact me at my number or you can mail me. Thank you.